All right, so here we go for intermediate algebra concepts, Unit 1, Notes 1. So a lot of this stuff is stuff that you have seen in 8th grade, but we got to review it and we got to strengthen it and get better with it. So here's where we're going to start. We're going to start with just simple solving equations. Remember, anything with an equal sign is an equation. Without an equal sign is called an expression. So how you solve equations when there's a couple steps you got to do. Well, 4 steps that need to be in your notes are right here. Simplify each side of the equal sign by distributing and combining like terms. That means getting rid of things like parentheses, or getting rid of something if I've got like 3x and 5x, but they're on the same side of the equation. That is where I need to simplify that into just 8x. So you got to make it as simple as possible. Step 2, gather the variables to one side of the equal sign. So if I've got 4x, but then on the other side of the equation I've got 2x minus 6, well, I've got variables on both sides, so that means I need to get them over one of them over to the other side, get everything on one side. So to do that, I'm going to subtract 2x, because this zeroes out. That becomes 0. 4x minus 2x is going to be 2x equals 6. So now I've got the variable all by itself. So then use addition or subtraction to cancel constant. We don't have that here, but what that would look like would be if I had x plus 4 equals 10. You'd subtract 4, so it'd be 6. Then use multiplication or division to cancel the coefficient. So if I brought this down here, 2x equals 6. So that's multiplication, so I need to do division. 2 divided by 2 is 1, so x is going to be equal to 3. That's going to be the 4 steps on what I got to do to solve my equation. So solve the following equations. So x plus 5x minus 5 equals 1. So the good news is I've already got all my variables on one side. All right, I've got that. Those are my 2 variable spots. They are all on one side. But what I have to do is put these things together. So x plus 5x is going to be 6x plus 6x minus 5 equals 1. Now, a lot of kids will look at this and they will give me something like 5x squared. They'll put the x's together like that. Don't do that. This is the equivalent of saying 1x plus 5x. So now, add 5 to both sides. 6x equals 6. Now divide. All right, sorry, let me back up here. I'm adding 5 here because I have minus 5 in the problem. So when I do that, that gives me 0. 1 plus 5 is 6. Now I'm multiplying 6 times x, so I got to divide. 6 over 6 is a fancy way of saying 1, but 6 over 6 on this side is also 1. There's my answer. X is going to equal 1. Second one, 3a minus 4a plus 6 equals 8. So 3a minus 4a is really a fancy way of saying negative 1a plus 6 equals 8, or just negative a. Either way is fine. So now, subtract 6. Negative a is going to equal 2. Okay, plus 6 here means I've got to do a subtraction of 6. So that becomes 0. So negative a equals 2. I remember what I said, this is like kind of having a negative 1. So to get rid of the negative, I'm actually going to just divide by the exact same thing. So I'm just going to divide by negative 1. Okay, that's what you do when you have just a negative variable. Just multiply it or divide it by negative 1. All that happens is the signs change. So negative a equal positive 2. So positive a is going to equal negative 2. So here we got to take care of some parentheses. So actually more than one way you can do this. One way to do this might be to kind of trust your instincts, distribute. So that's going to be 24 minus 12x equals 36. So now, good news is I've got everything over on one side. I got my variable on one side, but I got to get rid of everything else. So since I got a positive 24, I'm going to subtract 24. Be careful with this sign. This sign is in front of 12. It's not in front of 24. So you don't want to add 24. You want to subtract 24. This becomes 0. Negative 12x now equals 12. So now you've got a negative 12. So I want to divide by negative 12. So x is going to equal negative 1. All right, negative 12 over negative 12 just becomes 1. So my answer is going to be negative 1. All right, let's take a look at this one. Here you've got it on both sides. You've got a problem on both sides. So what I need to do is, first thing, add 2x to both sides. You could subtract 6x over, that's fine, but I want to add 2x because here's what's going to happen. That's going to zero out. You're going to get 8x minus 11 equals 5. So now I'm going to add 11. So 8x equals 16. That becomes 0. Divide by 8. Divide by 8. So that's going to be 1. So x is going to equal 16 over 8, better known as 2. Okay, so if you got to pause, back it up, rewatch those, please do, so you kind of get that solidified in your head. So what happens if I change things up a little bit? So negative 2 plus 10p equals 8p minus 1. So what you're looking at is this. You've got 10p and 8p. And you got negative 2 and negative 1. So all the variables need to go on one side, get everything else to the other. So what I'm going to do is say I'm going to subtract 8p from both sides. So that kind of becomes 0. So I've got negative 2, 10p, plus 10p minus 8p is plus 2p, and then minus 1. So I'm going to add 2 to both sides. That's going to be 1. So p should equal 1 over 2, or 1/2. I just divided by 2 there. So negative 4, x minus 3, so it's going to be negative 4x. When I take this negative through, notice I bring the negative with it. Okay, when I take that 4 through, I bring the negative with it. That's why it's negative 4x. Then it becomes positive 12 equals negative x. Now notice, I've got negative 4x plus 12 on the left, negative x on the right. I want to get all my variables to one side, but if I try and take this over here, if I add that over, then I've got everything on one side and nothing on the right side, and that kind of creates some work for me. So I don't want that. I want less work than I have to do. So what I'm going to do instead is add 4x over. This does two things. It gets rid of negatives, which kind of tends to confuse people. The second thing is that it automatically puts one thing on the left and one thing on the right. Okay, my numbers on the left, my variables on the right. All right, this zeroes out. Divide by 3. That becomes 1. This becomes 4. So my answer is going to be 4. Oop. So 2m plus 5, 5m minus 7 minus 3m. So a lot going on in this one. So throw that through. So 2m plus 5 equals 5m minus 35 minus 3m. All I did was distribute that through. 5 times m is 5m, 5 times 7 is 35. So this stays 2m plus 5. On this side, I want to put that together. So 5m and 3m is going to be 2m minus 35. Now, here's something interesting is going to happen here. If I subtract 2m over, to try and get all my variables onto one side, that zeroes out. But look what happens over here. This also zeroes out. So I'm left with 5 equaling negative 35. Well, that's not a solution. All right, this is kind of what we call a mathematical statement. And is that statement ever true? No, 5 is never equal to negative 35. So my answer is going to be no solution. That's going to be my answer to that one. Likewise, if you're kind of ever working through a problem and you get something that's always true, that's going to be infinite solutions. The answer is going to be what we call all real numbers. All right, so let's take a look at this one. So if I have 3r plus 3, make sure you take it all the way through, equals 3r minus 2. So now simplify this. 3r minus 2 equals 3r minus 2. Do you notice how you have the same thing on both sides? All right, something's going to happen here. Now watch. I subtract 3r from both sides. This zeroes out, this zeroes out. Negative 2 equals negative 2. This is always true. Okay, negative 2 always equals negative 2. It's never different. That is what we call all real numbers. Okay? Any number that is real, you could put in there and get that answer. All right? That's how that works. So when you're looking at equations, Kevin. Now, when you got fractions in there, now things get a little bit trickier. So negative 10 equals 1/2 x plus x. So think about this as a 1x. So you got 1 plus 1/2, 1 plus a half. So that means negative 10 is really equal to 1.5, or in this case, it's easier to put it into an improper fraction. It looked like that. So now how do I get rid of that? Well, when you get rid of a fraction, you end up multiplying by the reciprocal. So if it's 3/2, then that's got to be 2/3. All right, and you kind of mathematically what you're doing is killing two birds with one stone. Okay, if I've got 3/2 x, and I've got to get rid of that, well, I've got to do two things. I've got to multiply both sides by 2, because that cancels that out. And then I've got to multiply it by 1/3 or divide it by 3, and that cancels that out. This does that in one step. All right? So 3 cancels out, 2 cancels out, it becomes 1. I'm left with x. On this side, I've got 2/3 times 10. Okay, so times negative 10. So that becomes negative 20/3. So that becomes negative 6 2/3. Simplified. That's what that is. So here, you got a little bit messier one. You got parentheses on both sides. You got variables on both sides, and you got fractions and all sorts of craziness in here. So first things first, get rid of parentheses. This is going to be 8r minus 32. This side, when I distribute this, this kind of works out nicely actually. 49 divided by 7 is just 7r. 49r times 1/7 is like 49 divided by 7. 70 divided by 7 is going to be just 10. So now this looks a lot cleaner, a lot easier to put together. So subtract 7r to get all my variables onto one side. That zeroes out. So now this gives me r minus 32 equals 10. So I got to add 32 to both sides. R is going to equal 42. There's my answer. Gonna be sneaking in here. You have a fraction equal to a fraction. So kind of what you need to do is multiply diagonally and do what we call cross products. Okay, essentially what you're doing is you're going to multiply both sides by 3. That's going to cancel that out. So you'll have 3x over 2 equaling x minus 2. Now multiply both sides by 2. You'll get 3x equals 2x minus 4. This is like distribution up back here. So subtract 2x. X is going to equal negative 4. So your school is building a new computer lab. 400 square feet of the lab will be available for computer stations. Each station requires 20 square feet. Write and solve an equation to find out how many computer stations can be put in the lab. So if we let C represent the square footage of each computer, so of each station really, of each computer station. So each one requires 20 square feet. We have a grand total of 400 to work with. So 20 times C has got to be up to 400. So you're looking at up to 400. So divided by 20, divided by 20, C is going to be equal to 20. So that means we can have 20 computer stations. So Hugo is buying a pair of water skis that are on sale for 2/3 the original price. After he uses a $25 gift card, the total cost before taxes is $115. What was the original price of the skis? Okay. So what was the original price of the skis? Okay, we're going to call that, P for the original price. So what you need to look at here is kind of what am I dealing with? So if P is the original price, then here's kind of the way I want you to look at it. All right, so 2/3 of the original price, and then he used a $25 gift card. Okay, so we're going to take the original price, 2/3 of that minus 25, and that's going to equal 115 bucks. All right, so 2/3 of the original price, and he used a $25 gift card, so knock off $25. And this is the cost before taxes. So if I add 25, and I guess the setup is kind of the really important part. Remember, you're taking $25 off for the gift card. So that's what I'm going to add here. So that becomes 0. This becomes 140. So multiply by 3/2. So remember, you're kind of getting rid of that. That cancels out. You're left with just a variable. So it's 140 times 3/2. So in the short and easy way to do it, 140 divided by 2 is 70, times 3 is 210. So the original cost is going to be $210. That's all we got. Get going on your notes and your assignment and get ready for the quiz.